Hello. Unfortunately, I managed to break my analog discovery again. This time, well, it wasn't that long ago. I did a repair on it because I had broken the micro USB connection. But this time, unfortunately, I had it hooked up, sitting on the table with some stuff connected, and then one of our cute little cats decided this should be on the floor instead and managed to push it down. So it was a bit unfortunate because this time the USB socket has been completely ripped off the board. Got the cable here with the socket, and unfortunately it looks like some of the pads got ripped off here as well, so it's going to be quite difficult to repair this time, I think. Anyway, let me try to set up a microscope and then we can have a closer look at how bad it actually looks. Okay, so I have a cheap little microscope set up here with just using my tablet as a screen here, and see if we can see what's going on here. Okay, there we are. That looks like the USB connector. My finger. I hope you can see that on camera, but it's quite clear that at least one pad has been ripped off. Luckily, the rest of them look okay, but it looks like this is probably the two data. So this is probably plus 5 volt data, this ID thing, and negative here. But there's a pad missing here. There's a trace here. You probably scrape a little bit more off here to see if we can solder something onto there, but it is very, very small. This, if you look here, this is a resistor. If you compare it here to how large that is, so you can kind of get an idea. This is going to be very fiddly to solder anything on there. Anyway, I'm going to give it a go. So I think, let me see if I need to find some wire. I think I have some really thin wire, and I think I have the old USB socket here. Doesn't look so pretty, but we can actually see there's the pad is sitting here, unfortunately. So not great. I don't think I'll solder in a socket again. I think I'll just cut the cable and just solder it in directly here, and then see if I can make it really, really sturdy. So even if it falls down again, it's not going to rip off any of the soldering on the board. Okay, let me find some wire and then we see if it will be possible to solder this in. So I found a few different types of wire. Normally I use this wire wrapping wire for circuit board repair, but it might just be a little bit too thick for some of the repair we have to do here. I'll put it in a microscope here, kind of get a feel for it. Yeah. Well, it might do fine for the normal pads, but I think the one here for repair, the one where we have to fix the trace, or the pad is missing, I might need something a little bit thinner. So I have some magnet wire. This is a, let's see, 0.25 millimeters. It might work quite well. It's not that much different from the wrapping wire. I also have a thinner magnet wire. This one is 34 AWG, so I think that's about, what is that, like 0.15 millimeters or something. Yeah, I think that would be quite good for the one with the missing pad here. So I think I want to try solder that one in first, because that's definitely going to be the most difficult one. But before I can do it, I need to remove a little bit more of the top coating, so we can expose a little bit more copper. I don't think this is enough to, not enough to solder anything on there. So I'm gonna go ahead and do that. So I don't think I can do that on camera. Usually I just use like a small loop, something like this, when I have to do really small repair work, or maybe a slightly larger like this. That works quite well, but I can't really get that on camera because my head is gonna be in the way. So I'm just gonna try scrape a little bit off, and then we can have a look again. Okay, so I have exposed a bit more of the trays here, so I think that should be enough that we can start soldering onto it. Yeah, I think that will work. So first I'm just going to clean up the existing solder here, get some fresh solder on there, and then we'll start getting these fiddly wires on. So I found a USB cable here. I believe that's fairly good quality, and it's a little bit longer than the other one I had here. This is quite short. So I think I will try cut this one and solder it in directly. So I need to figure out as well how I want to secure it. I need to have some kind of support. I think maybe I can drill some holes in the casing, and maybe add some zip ties or something, just to hold it very, very securely. So if it falls out again, well, if it falls down again, it's unlikely to rip off all the cable. So let me just cut this one. I don't know what it's gonna look like inside, so I hope it's something that's actually we can work with. So it's got like fancy looking sleeve outside, so but it's really what's inside it's interesting. So I hope it's going to be decent quality and copper wiring. Okay, it's a bit weird. So what is this? So we got 4 connectors. I guess the thick red one must be plus 5 volts. This is probably, well, this must be the shielding. It doesn't look like it's really shielding. It's just a wire, and maybe this is the ground and this is the shielding. I'm not actually sure. I'll have to do a measure on this, but I think these two are going to be the data, so positive and negative data. I just need to find some color codes and pinouts, and I think we're going to have to do some measurements, so I'm just going to do this end as well, and we can measure on a socket. Just make sure we get it right. Okay, so I've finished measuring the cable here, and this is the way I'm going to solder it in. It's going to be red, white, green, nothing, and then the ground connection going on to these pads here. So next step, time to clean the existing pads and see if we can start soldering in, see if we can do it without shorting anything. Okay, so let's go add some flux. Yep. It's so tiny, it's really hard to see what's going on. Okay. Let's have a look and see what it looks like. Can't really see anything, it's so messy. Okay, let's clean with a little bit of alcohol. it will come out. Okay, that looks okay. So I'll try to see if I can solder on first this really thin wire here. I'm not going to be able to show it very much on camera, but let's see how it goes. Okay, I believe I got the wire soldered in. Right now it's very fiddly. Sorry, I couldn't do that on camera. It's I had to get my nose all the way down in it. Just clean it a little bit here with some alcohol. So we got plus 5 volts. I think it's positive data, negative data, nothing, and a negative here. It's incredibly small. I mean, even you can see my probe tip here coming in. That's kind of the sizes we're working with, right? So, well, it doesn't look like anything is shorted. So now comes the second part of the operation. I need to get the USB cable mounted somehow inside the plastic casing and secured, and then I think it's gonna go through a hole and then bend it around something like this, and then get some zip ties or something to the outside of the casing. Hopefully that will hold it very secure. So I'm gonna have to give that a go. So that's gonna be tricky as well. Okay, so let's have a look at how we can get this cable securely mounted inside the case here. So I think there's enough space. I'm thinking about just drilling a hole down here, have the cable come up through here, and then coming back on the outside here, and then perhaps have a couple of drill some holes here, have a couple of zip ties, just hold it securely. It is tempting to try have it all hidden inside, but I don't think it's gonna be possible. I think it'll be too much trouble, and really I don't care what it looks like as long as it works. It's gonna look a little bit Frankenstein, but hey, as long as it works, then that's fine. And should it break again, then I'll probably have to bite the bullet and I'll buy a new one. I think we're getting to a point where if I get more traces ripped off here, it's going to be extremely hard to repair. So yeah, I think I'm just going to drill some holes in the case here. One hole over here, maybe 1, 2, 3, 4, 5 holes in all here. Okay, I'm ready to start doing some drilling. So I think the cable will come up over here. I think that will work fairly well. So this is the USB interface, FPGA, so all this is digital and all the analog stuff is over here, so it shouldn't really disturb anything. So I think I'll just go ahead and drill some holes. So let's say here, just to mark it. Yeah, I think that will work fairly well. Just use a small wood block, see if we can avoid cracking the plastic. Got a drill here. I think we're through. So hopefully the cable should fit through here. Like this. It will go inside here, connect it, and then run it on the outside here. And attach a couple of zip ties here, just for strain relief, and I think that will work quite well. Yeah, not too close. Yeah, and yeah, take a bit. So I'm just going to slowly because it goes plastic, you also set the frozen weight, and the rest is going to snap, and it's going to break plastic. Pressing it very slowly. There we go, no problems. So yeah, this is kind of the idea, right? So it comes out of the hole here, and we have two zip ties here for strain relief, and then it's gonna hold the whole case in place. So before I solder anything together, I need to make sure it goes through the hole here. And then comes the tricky part. We need to get these soldered together. So I think maybe I should just maybe I can just put a small drop of glue on the FPGA here and just hold it a little bit, at least while I'm doing the soldering. Not sure about super glue. Problem with super glue is always that it tends to create fumes, and those fumes are gonna like create a layer on top of things. So I'm not really a big fan of super glue. So let me try this. It might take a little bit longer to dry. Okay. Okay, just come back a few minutes. Okay, we'll just leave it there for a bit. Okay, so at least it's not quite dry yet, but at least it's kind of sitting in there. See if it will hold long enough for me to solder these wires together. So the first one is going to be the power. So I have various sizes of some heat string here. This one probably works here. Okay, that's good. Yeah, okay, and next one's white, and this is the line. Cut here. So I'm going to switch. Okay, so starting somebody else will show here. I don't know if you can see what I'm doing, because it's very small way to do. I'm just speed up everything else. Okay. So I think now would be a good time to test if it still works. I have to be a little bit lucky, I think. Maybe I should. I think this will do. It shouldn't move around too much inside. So I think I'm just gonna take it to my laptop and try hook it in, plug it in, see what happens. Hopefully it will work. Amazingly, it seems to be working. So now we just need to get everything secured, and then it should be back in business, and I should be able to make some updates I've been waiting to make to my both my what's this? My audio analyzer suite, and also I would like to release the impedance analyzer, and then people can do with it whatever they want. Let's see if we can do this without any major accidents. Let's see why it's coming up here. So need a bit of a dent there. Okay. Hopefully that's okay. Get the screws in. I can find a screwdriver. Can use one of these. Okay, so I think this seems to be fairly good strain relief. Like that. Okay. So, well, that's it. Another repair. Probably going to be the last one for this device here, but I'm pretty sure next time it's not going to rip off the cable here. You will have to break the case and everything. So maybe I should close off this a little bit. But hey, if it works, we're back in business, and I can do a couple of software updates and take it from there. Thanks for watching. I hope you're going to have a nice day. I'll see you next time. Bye bye.